Hey everyone, welcome to Code Harmony. Today we are going to solve this LeetCode problem 2658, maximum number of fish in a grid. This question has been asked in Adobe and it's based out of graph. This question is very similar to the question number of island. This is a pretty simple problem on LeetCode. Okay, now let's have a look on the problem statement, what's given to us and what we have to do. We are given a grid of size m cross n where every cell in that grid represent either a land or water. If the grid value is 0, it means that is a land. If that is non-zero or some value, it means that is a water. Containing grid RC fish, it means whatever is the value, that number of fish are containing in that grid. If we just have a look on this example, let's say this is a grid, this 0 represents land portion, and 2 is representing that this cell is containing 2 fishes. A fisher can start at any water cell, okay, and do this operation. Catch all the fish in that cell and move to any adjacent water cell. And what is an adjacent water cell? If this is the cell, we can go in these 4 directions. Right, left, top, down, like this. In more 4 direction. Okay, what we have to return? Maximum number of fish a fisher can catch if he start to choose optimally. So what the problem is saying? Problem is saying that this is the water cell and all the non-zero are the water cell and the 0, these are the land portion. It means there is no water, no fish. But if we move to these portion 2, 1, 3, 4, 3, 2, 1, 4, these are the water cell where the number is number of fish in it, and a fisher have to calculate all the fishes or the maximum number of fishes he can collect. And apart from that, let's say he is at this location, so from this cell he can move only these 4 direction. Okay, so zero cell he is not going to visit. So this is 0, he is not going to visit. He is going to visit this one, and this is the adjacent, this one he is also going to visit. And apart from that, if we start with this 4 he can visit, 1 he can visit. And what about the other cell? 3 is water cell with 3 number of fishes, this he can visit, and 2 is in the right, so 2 can also be visited. Now these 2 are also the fisherman is going to collect. So what we are saying is that if let's say he is starting from 2, if he is starting from 2, he can go to 1. That's all. There is no other direction. And now later on, if we start from 4, he can go to this one again. This one. I'm just marking the value, but you assume that this is the index I am marking. So if this 3 he is going, he can go to 4. If this 3, then he can go to 2. And now if you try to think these values, these ij values as a graph node, and these are the edges. So we are currently having 4 graphs. Graph 1, graph 2, graph 3 and graph 4. And as these 4 graphs are connected in the right manner, like right down, top, right, left, top, down. So it means the fisherman can collect all the fishes from this graph. And in the problem statement, it is given that maximum number of fish the fisherman can catch if he choose to start cell optimally. Okay, it means it is not given an option to the fisherman that he can collect all the fishes. He have to start it optimally. It means from all of these graphs, he can only visit a single graph. Let's say if he is starting from 3, then he can go to 4. In this case, the answer is 7. Here the answer is 3. Here the answer would be 5, and this is also 5. So this is the maximum answer. So he will definitely start from this cell and he will go to this cell. So this is the fisherman have to do. Okay. So this grid is given to us, and in this grid we just have to find out what is the connected component or connected graph component that is going to give us the maximum sum. because the value here is the number of fishes, and optimally the fisherman also want to maximize the number of fishes. So what are these 4 values? These are connected components. Connected components in a graph. So whatever is the connected component, just find out sum of all the nodes in the connected components. So this is our problem statement now. The problem has reduced to finding connected component or finding all the all the graphs within this graph, connected graphs. Okay, so how do we do this? Let's say we are starting from 2. From 2 we can go to 1 only, and then even let's say we are doing it recursively, we are not able to move further. Okay, if we start from 4 we can only go to 1. If we start from 3 we can only go to 2. If we start from this 3 we can only go to this 4. Okay, so in 4 stages we are going to get our answer. And you have noticed that every time I have started from a cell which is containing water. So it is clear that we have to start from a cell which is containing water, and then we can keep exploring the direction, and we can keep going in the connected water cell to catch the number of fishes. Okay, so this step, how do we do it? In graph, when we have to visit all the connected components, we are definitely going to start from water cell. And after that it's totally up to you whether you want to do the DFS, you do the DFS. If you want to do the BFS, you do it. And there is one more fancy algorithm which is called disjoint set, or you can say union find. But let's try to do it with the DFS. So DFS is the approach that we are going to pick, and after that we'll keep track of our answer. Let's say my answer is this, and initially if there is no water cell, how many fishes he can collect? Minimum 0 number of fishes he can collect. Okay, so initializing my variable with 0, not the minus infinity. Okay, so we have to do the DFS. DFS means we are doing it recursively. Let's say we are starting from ij. We are definitely going to start with ij if it is a water cell. So let's say we are exploring the water cell. First water cell we have encountered is this. Okay, this we have encountered, and while doing a DFS call we can maintain a counter. We will keep on adding the value in that counter, and ultimately after that DFS call we can compare whether this counter is giving me better result than in this answer or not. Okay, from 2 we have started, and from 2 we can go to 1. Okay, and now from 1 we cannot move further. It means we are done with our DFS call, and yeah, we definitely have to go to these 4 direction. So let's say from 2 it is coming to 1, and from 1 it can also come to 2. So we also need to take care of visited nodes. When we are coming to 2, we have captured our counter plus equal to 2. So it means we have utilized the value of 2, and now we can mark it visited. Either you can take a visited array, 2D array, or you just do one thing. Apply the shortcut to make its value 0. If I just make it value 0, we don't require the number of fishes again, because we have already captured. So from 0 2 we have already captured. We are going to one direction. So in the direction of 1 we are going ahead, and our counter is again incremented to 2 plus 1, and its value also I'm going to make 0. And now from this position it is not going in the left direction, because in the left direction it is 0. So we will go only in any direction if it is a valid I, valid j, or if it is not equal to 0, because 0 is a land portion. We consider it as a land portion so that we will not be able to move ahead. Okay, so this current DFS is over, and now current count is 3. 3 is better than answer, so mark it here. And now let's come here, starting my DFS from 4, marking it 0, and 4 is also added to my counter. Okay, and now we can go to the lower direction, bottom direction. This is 1 is also added, and 1 is also marked as 0, and now we cannot go in any direction. So answer is 5. 5 is better than 3, So discard 3 and capture 5. And now what is the next voter cell? Next voter cell is 3. So if I just start with 3 and 3 to my counter and mark it visited, and then there is one possibility to go, this is 2, adding 2 to my answer and marking it visited, the answer is 5. 5 is not better than my current answer, so we'll not capture it. So next voter cell is 3. Capture 3 and now make it visited. Now capture 4, make it visited. Ultimately I answered is 7. So 7 is better than my answer. I'm just capturing it. After capturing 7, there is no voter cell remaining in this grid or graph. And now my ultimate answer is 7. So one thing is that we are starting from every voter cell. So if it is from every voter cell, I equal to 0, I less than m, I plus plus. For every I, for every j equal to 0, j less than n. I will go from 0 to m, j's go from 0 to n because the grid is of size m cross n. Now if this is a voter cell, if the grid I, j not equal to 0. If it is not equal to 0 means that it is a voter cell, and if it is a voter cell we can just initiate the DFS from this I and j direction. This is going to be from my main function. Now this DFS is captured, and now for every DFS I am utilizing a counter. So you just maintain a counter variable, count equal to 0 in the starting, and now count, if count is becoming greater than maximum, then maximum is equal to count. So this is my if condition, and this is my for condition, and this is my outer for loop. So this is going to be from my main function. For every unvisited, or you can say every voter node, for every voter cell I'm going to initiate my DFS. And while doing the DFS, I'm going to go in the for direction. So what is this DFS function? Let me write this DFS as well. DFS is going to take 2 parameter ij. And what about this grid? I can keep it global, m global, n global. And what is count? Count is also global. Keep it global so that we don't mess around with the parameters. Okay. I'm not returning anything. Okay, so this is the DFS function. First of all, if I and j are not valid, if I and j is not valid, then we can directly return. There is no use of it. Otherwise, it means I and j is a valid voter cell. If it is a valid voter cell, then increment my count. Count plus equal to grid of I and j. Count is updated. And now what you have to do is, you have to explore 4 direction, right, down, left, up. So if the current cell is ij, on the right side, j plus 1, and it is j minus 1, it is I minus 1, I plus 1, according to the grid, if the top left cell is 0, 0. Okay, so these 4 direction is already given. We can store it in a direction array. This, and these 4 direction array we can capture. Let's say 0, 1, 0, minus 1, 1, 0, minus 1, 0. See, this is my dir, direction array. So I am going to explore every direction integer array. Let's say this is the direction. This is the dir, 2D array. What is my new I? Updated I is current I plus direction of 0. Updated j is equal to current j plus direction of 1. So this is my new I and new j, and I'm going to initiate the DFS call with new I and new j. So this I'm going to do for all the direction. And apart from that, do I have to do anything? No, nothing is required. So this is the DFS function from any starting index. If that index is not valid, just directly return. Otherwise, capture the value. It means to capture the number of fishes we have encountered. And now go to all four direction. What is the valid function now? When will the ij not be valid? If I is less than 0, j is less than 0, I is equal to m, j is equal to n. These are not valid. If value of grid is equal to 0, it means a land portion, it is also not valid. And there is one more thing which is missing. When we are marking it visited, so after capturing the value, we are capturing the value here. After this, we should also mark it visited. So grid of I and j is equal to 0, so that on the next portion it is not captured again and again. So that's all about my function. And what is the time and space complexity of it? It will be pretty simple, because every time what we are doing, ultimately we are capturing every single row, and if it is not visited or the cell value contain value greater than 0, from that we can start our DFS, and DFS will also capture every cell only once. So every cell is going to be either one time using this loop, and if we are coming to DFS, only one time it is going to be captured. So we are not going every single cell more than 2 times. So it will be m plus n, number of cells equal to the number of cell. And what about the space complexity in this case? Here what I have done is I have utilized the given input to track my visited cells. If you are taking separate visited array, then you might have a separate space, but in this case I have not taken any extra space. But if you also consider the space utilized by DFS tag, then that can also go till m plus n. So it would be better if we just mark it m plus n to be precise. Now let's have a look on the code. I have done the same what we discussed in our algorithm. So this is the main function, and in the main function I am going to start my DFS from every voter cell. So this is to capture every cell in a grid, and if the cell is voter cell, then there is a variable I'm going to keep track of, which is going to keep on capturing number of fishes in the cell. And then DFS is starting. From starting of DFS, I'm just making it 0. And then after DFS, I will see whether this value is greater than the maximum value or not. And maximum value should be initialized with 0, because 0 is the minimum possibility. And in the end, just return maximum. This is our function. And what is this DFS? DFS is starting from a cell. That cell is a voter cell. Okay. And now it is further calling DFS function. So it might come to a cell which is not a voter cell. So firstly we need to see whether this cell is valid or not. If it is going out of bound, and the second option is it is going to a land cell. And we are also utilizing 0 to mark a cell, mark a voter cell and making it a land. So now if it is coming to line number 32, it means that this grid cell is a valid voter cell, and whatever is the number of fishes in that cell, just capture that in temp variable. After that, mark it visited and explore all the direction. All the direction means updated value of I, updated value of j, and do the same DFS call. So this is our function, and it must be working fine. I'm submitting this function. It's submitted successfully, and you can also do it with BFS and distance, but yeah, this is the pretty simple and straightforward approach. Also the constraints are not so high in this problem, so you can go ahead with this approach. Okay, I hope you understood the approach. Thank you guys, bye bye.